Demystifying Machine Learning, Introduction to Artificial Intelligence, with Paige Bailey.
So hello everyone, today we're going to be talking about artificial intelligence. And you've probably heard a lot about it, like maybe your boss has posted some salaries and you want to get involved with machine learning because, you know, it seems like a lucrative new great career, or you want to know how to install a machine learning to your business process or something of that nature. So today we're going to be discussing what it actually is and how you can start using it, even though you might not necessarily have a degree in computer science or machine learning or something. So to start with, I'm Paige Bailey. I do things with computers sometimes of varying degrees of quality. My background is geophysics and applied math, and then some work in carbonate geology and computer science. I've had about 10 years of experience with Python and 4 with R, which is why I tend to talk about them more. Those two are also the primary languages of machine learning. So if you have any questions about anything as we go along, or if you want to talk about machine learning further, hit me up on Twitter. I'm Dynamic Web Page, and then also I'm happy to answer any project related or Azure related questions that you might have too. So the roadmap for today, we're going to be talking about what exactly is artificial intelligence, how is it used, so some tangible use cases, and then also a discussion of how you can get started with it today. So is there a way that you can incorporate predictive modeling into your workflow without necessarily having to train or to test a data set? So to start with, what is artificial intelligence? And artificial intelligence has been around for a while, right? Like probably since the 1950s. And its definition is that it's any technique that enables computers to mimic human behavior. And you can think of this in a wide variety of ways, right? So it can be you give a computer an input and it can sort of give you a tangible response that's been hard-coded. But artificial intelligence, very, very broad category. Within artificial intelligence, there's a subset called machine learning, and this is where stuff starts to get interesting. So machine learning is the ability to learn without being explicitly programmed. So instead of having to say a bunch of if-else statements that are very, very specific to a particular use case, instead of being given a problem and having to break it down into constituent parts, some of that tedium is alleviated from you as a developer, and you can just give a data set to a computer with some specifications, and the computer can begin to classify it. So what does that mean exactly? This is an example of kind of the different categories that you would have for machine learning. So if you have labeled data, so for example, you have a loan decision matrix that you know if people defaulted on their loan or if they didn't, if they paid their loan back or if they didn't, that could be considered labeled data. Or say you have like a picture of a cat and it's labeled as a cat, that would also be considered labeled data. So the two different subdisciplines of machine learning are supervised and unsupervised. So if you have labeled data, you would want to predict a category or a quantity. And the category would be a classification task. So that was an example of the loan model that we talked about before. You wanted to say yes or no, a person defaulted or not. Or you want to classify a person as having good health, fair health, or bad health. That would be a classification task. And some examples of this are SVMs, which are support vector machines. You've probably heard of those. The CIRTs, which are classification and regression trees, KNN, which is K nearest neighbors, and hundreds, if not thousands of others. There are a million, well, I don't want to say a million, that's a little hyperbolic, but there are a lot of different machine learning algorithms that you can use to help solve your problems. And learning how to select the correct one or the correct one for a given data set or a given problem is definitely an art. And more often than not, there are a variety of machine learning algorithms that could be well suited to your task. So if instead of trying to predict a category, you're trying to predict a quantity, so a numeric value, you would want to do a regression. And a regression, you can do things like linear regression, you can do lassos. And the cool thing is about this is if you've ever done, so if you've ever pulled data into Excel and you've done kind of a right-click plot it, and you have a scatter plot, and then you have a line of best fit going through those points, congratulations, you've done machine learning, because adding a line of best fit, that's a linear regression. And that technically could be considered a predictive model, right? Like y equals mx plus b is the equation of a line. If you give an x into this equation for a line, you'll always know what your y response is going to be. So that's kind of cool, I think, like that a machine learning algorithm can be as simple as a line of best fit. And then, so say you don't have labeled data, you don't have really anything to work with, though you do kind of know which question you're trying to answer. Then it gets a little bit more difficult. So this is called unsupervised learning. And the first thing that you have to do is figure out ways to group the data that you have. And you can do this a couple of ways. So there's something called cluster analysis. And two examples of this would be k-means or hierarchical clustering. The example I always like to give is kids in high school, right? They usually fall into specific categories like jocks, theater kids, band nerds, and each of those subgroups have different characteristics, right? So if you like sports, if you like I don't know, pizza, if you like going to football games, you like wearing jerseys, then you'll probably be tending to cluster with kind of the other people with like-minded jock characteristics. And that would be an example of cluster analysis. And then dimensionality reduction, we're not really going to talk about for the rest of the talk, but it's things like principal component analysis and then independent component analysis. And there's also something called kernel PCA. But that's all about kind of understanding your data a little bit better. So that's machine learning. These are kind of the examples of what you would want to do with machine learning. And that's a lot of words on a screen, and a lot of words on a screen is always confusing. So let's have an example. So say you get this CSV file or table in a database from your boss, like our customers.csv or whatever it's called. And as part of this our customers data set, you have information about a person's age, whether or not they have a job or they own a house, or what their credit rating is, what kind of education they've received, and then also whether or not they defaulted on a loan. So if they defaulted on a loan, then that means they did not pay it back. If they did not default on a loan, that means they did pay it back. And if you're a person who's in the business of loan giving, really all you care about is whether or not you're going to get your money back with interest, right? Like that's honestly the only thing that you want to know. And you obviously would want to predict on that, right? Like if somebody applies for a loan and you could say with some confidence level, all right, like I'm 85% confident that you'll pay it back. That's a pretty high level of confidence. Let's go with that. So how would you go about creating that process? If you got this new potential customer, right? So somebody who's 35, who has a job, who doesn't own a house, who has a bad credit rating, but has had secondary education. So let's see what you would get if you implemented a machine learning algorithm called a decision tree would be something like this. You would have a series of questions that you could ask, potential responses to those questions, and you would get this. So the age, the person's in their 30s. They have a job, but they don't have a house. So that was that third thing. And they do have education. So the example that you would, the example here, you would be able to give a loan. If they had different responding answers, so for example, if they were in their 20s, they didn't have a job and they had poor credit, then you probably wouldn't want to give them a loan. But that's really all a machine learning algorithm is. It's a series of steps you can do to kind of determine how a question should be classified, or a given record in a data set should be classified. So this is, it sounds like magic, right? But it's actually problematic in a number of ways, right? Like it could be useful, but let's take a look at some of the ethical considerations, some of the tuning that you have to do on the data. Machine learning usually requires knowing which algorithm to select. It requires getting your data into a necessary state, right? Like how often do you see data that actually looks like that, right? Like instead of, having a job being yes or no, one or the other, you might have something that doesn't even make sense, like fluffy pink bunny embedded within one of the columns, or you might have NA values, or some of these might be encoded as text rather than string. And those are all things that you would need to kind of massage into compliance if you wanted to stick something in a machine learning algorithm. You also might run into kind of unintentional age discrimination as you use some of the algorithms, right? Like, or maybe it discriminates against something else if you look at zip codes, or if you look at kind of educational status. So they're extremely useful, but they take a lot of specialized knowledge to implement correctly, and a lot of hyperparameter tuning, which is kind of nitpicking the algorithms to get them to answer your question to a high confidence level. So that was machine learning. And a subset of machine learning is called deep learning. And this is probably the one that you're most excited to hear more about, that you've probably heard buzzwording around the internet. And that's learning underlying features in data by using neural networks. And the selling point for this is always like, you don't have to do anything to your data. You get all of this feature engineering, which is the stuff I was just mentioning, the hard parts of machine learning, for free. And that's not necessarily the case. It hardly is, actually. But there are some options that you have for leveraging deep learning very effectively. So some ways that artificial intelligence is used, and in particular, I'm going to be talking about deep learning for these next items. You can do kind of automatic entity detection in images, right? So it can automatically spot objects versus people. This should be very important for self-driving cars, right? Like, make sure that if you're going to run into something, you run into a light post instead of a person. It can do kind of automatic age detection. So it can make an estimate of a person's age, an estimate of how happy they are. It can do it can detect who a person is, and even things that can change the world, right? Like detecting cancerous cells or tumors in lungs. So in images, deep learning has been incredibly effective. In text, that too, though I would argue not quite as effective. This is always my favorite example. They threw all of the Harry Potter books at a neural network, a deep neural network, and this is the response it gave. So Harry Potter and the portrait of what looked like a large pile of ash. And it's actually kind of funny to read through some of the text that's automatically generated based on all of the text for all of the Harry Potter novels that have been featured before. You can also do things like speech to text. So you have a person speaking and then that's automatically captioned. You can do automatic translations. So Google Translate, I believe Jeff Dean said that they went from, hundreds of thousands of lines of code to something like 500 lines of TensorFlow. Just magnificent advances with very, very few lines of code that have been tuned by experts and are on incredible hardware. And you can also do music generation. So it might not sound like Pearl Jam or whatever you happen to be into. But it is, you know, technically music, and it's getting better all the time. And there are a whole heck of a lot more that I don't really have time to go into. AlphaGo is a really popular example. There was a neural network that beat, I think it was Halo, or it like played a perfect game of Halo. Scott Guthrie is there off in the lower right, and that's an example of kind of the automatic age detection and person detection. So if you upload all of the images of your employees with their kind of names attached to those images, you would be able to automatically spot them in video cameras, which is kind of, you know, I can't decide if it's Snow Crash, like a Neil Stephenson novel, or if it's more like Big Brother, but whatever it is, it's really cool, but kind of scary. So lots of applications for deep learning. And it's become so popular recently for really 3 reasons, right? So we've had some of the basic constituent components of deep learning around for a while, like since 1950. So, you know, in the 80s, Geoffrey Hinton, who's considered the father of deep learning, started doing some of his work. We've been using kind of handwriting detection in the US Postal Service since the 1990s. But it was always kind of considered the place where good engineers go to die. Like if you told your advisor that you wanted to go to grad school to get a PhD in artificial intelligence, they were just like, no. Like, no, you know, go forth, young person. You have a massive, you know, programming knowledge. Don't go and waste your time learning artificial intelligence. But in the last 5 years, deep learning is suddenly more accurate than humans at classifying images, or at doing sort of the translation thing that I was talking about before. It's also really good at detecting voices and sound. We have specialized hardware that makes implementing deep learning models super fast, and actually kind of actually doable from a business context. So things like FPGAs, GPUs, and ASICs, which are kind of custom silicon. TPUs are an example, so tensor processing units. We also have a ton of data available, and a lot of it's becoming more and more classified. So huge sea of unstructured, unclassified data, but more and more is getting classified all the time. And those are the things that play really nicely with deep learning and with machine learning. I'd argue too that there have been additional tools. So for TensorFlow, perfect example, scikit-learn on the Python side and Caret on the R side, you have these packages that make it super friendly to just import a machine learning algorithm. And you can implement it, train it, test it, and get an output, usually with less than 15 lines of code. So the hard part, like I said, is the data and getting the hyperparameters tuned effectively. So what you've all come here today to learn, right? Like, how do I get me a machine learning? How do does the cloud come with the deep learning pre-installed? I don't know. But the good news is that if you want to get started with artificial intelligence, the internet is your oyster. There are tons of ways. And the 2 options that you have are either creating your own model, so doing all the hard work yourself, getting the data sorted, obtaining the hardware, or you can just deploy somebody else's model. So somebody else has done all the hard work and you can just call it as like a REST API. So let's talk about that first one, and then we'll go into the second. So creating your own model. An example would be a Jable case study that Microsoft has recently done. If you want to learn more, you can find out a lot about it at Build. But what the Jable folks asked was they had a series of chips on their circuit boards, right? Jable is one of the world's largest circuit board manufacturers. And what they wanted to know is, instead of having a person, like these people who look very bored, look at circuit boards and determine which chips have been installed correctly, could they have a deep neural network look at this chip and say, yes, that looks good, and look at that one and say, like, no, that chip has gone on vacation. So that was the use case. And over the course of 6 months, thousands of lines of code, pretty substantial and beefy deep learning machines on Azure. So they were GPU enabled, not FPGA enabled, I don't think. And they took quite a while to train, quite a while to implement. But they were able to classify very effectively. So that made sense in the context of a very specialized use case, right? Like this is a circuit board. Obviously, there are a bunch of components that need to be placed on the circuit board correctly. That is something that Jable would want to do, but probably the lady down the street wouldn't. You do have, and I just want to check the time, so I'll be going through this a little bit quickly, but I want to get to the part that, like I said, you're probably all here to know, which is how do I leverage deep learning models with all that overhead? So if you want to try out machine learning, I highly recommend scikit-learn if you're a Python person, and Carrot if you're an R person. But really, scikit-learn is the coolest kid on the block. If you want to do deep learning, highly recommend TensorFlow. Tons and tons of great documentation there. But you do have some additional framework options. It feels like everybody's making their own. It's like JavaScript, right? Like, you know, everybody thinks their puppy is the prettiest. So, but TensorFlow, trust me on that one. So if you don't want to take the time, if you don't have the data, if you don't necessarily have the experience in-house, and you don't have, you know, thousands of dollars to spend on customized hardware, you can deploy somebody else's model. And so say you have an idea, right? Like you have a favorite movie, and you think it would be really cool if you stuck emoji masks on the people's faces based on the emoji detecting and the text that you see on their faces, right? So Leia looks pretty angry. Han just looks kind of neutral. Or say, you know, Snapchat company wants you to create and you think that it would be great to put Harry Potter stuff on babies' faces. So that is also a really cool use case. What about, you know, politicians, right? Like, or celebrities, all of your favorite or least favorite people. Wouldn't it be really cool to put their faces on all of your friends' faces and make a GIF out of it, right? So all of these things, kind of, though they seem like different use cases at first, right? They're actually all the same, and that the only thing you need to know is where certain locations on a face are. Human faces are kind of universal, so they're a great use case. And then applying some sort of a mask or some sort of PNG images on top of it. So if there's a typical use case, there's probably somebody building a product for it, probably somebody who's been wanting to train based on, you know, millions of human faces before. And the good news is, this is another example for a language intelligence service. But the good news is that all of those use cases that I just mentioned have been implemented and can be implemented by you using something called cognitive services from Microsoft or recognition from Amazon or some of Google's deep learning APIs. And the other nice thing, all of it can be done with less than 10 lines of code. So this is an example here on the left for doing image detection, and an example on the right here for doing more text-based classifying. So doing automatic translation from English into a different language. So if you know enough to make a REST API call, you can leverage one of Amazon's, Google's, or Microsoft's deep learning algorithms. That's kind of cool. So some examples that we have at Microsoft, I'm not as familiar with Google's or Amazon's, though I'm sure they have great products available too. You can do emotion detection. You can detect specific people and images. So like when you upload a picture to Facebook and it very creepily says like, hey, do you want to tag yourself? We think we see you. You can implement that yourself. You can send an image in and get a text-based response back telling you precisely what is in that image. For speech, you can do the translation that I was talking about before. You can do spell check. You can do kind of sentiment analysis. So every time you type in a tweet and use the hashtag Azure, that tweet goes through a sentiment analysis to detect whether it's positive or negative. If it's negative, that tweet gets sent to a specialized Teams room and it also gets tagged with an IT support ticket. So if you say, oh man, Azure is awful, I hate Azure, hashtag Azure, then it gets tagged with an IT ticket and somebody has to respond. So if you want to make IT support people's lives kind of sad, like, go for it. But but it's kind of cool that you can implement that again, just using a few lines of code. And that particular service is implemented as a serverless function. So it costs negligible amounts of money per month. It's great. I feel like we live in the future. There are also things like knowledge. So if you want to do academic detection, how similar people are in terms of academic connections, auto-suggesting, getting back, the first 500 pictures that are classified as big lips and Bing search. And then also some things in our labs, which are mostly around routing and doing gesture detection. So cool things, very cool things. And if you want to learn more, I'm always available. I'm always online, literally always online. And there are a bunch of recommended resources that I have for you. So a lot of stuff out there is terrible, like very, very bad, don't do it, sort of terrible. But there is a lot of good stuff too. So Andrew Ng's courses on Coursera for machine learning and deep learning, I believe there are 2 specializations. They're fantastic. They're both worth your time and your money. There's an introduction to deep learning that was just put out by MIT. It's a week-long course, completely free. Highly recommend that as well. There's something called Data Camp, which Greg Wilson, if you're familiar with him, he's now one of the curriculum leads for. Everything they do is spot on. They get top industry machine learning and data engineering instructors. And then there's some great textbooks, formal coursework, and documentation. So I love Artificial Intelligence, a Modern Approach from Norvig and Russell. Peter Norvig's one of the heads of Google Brain. And then the docs for scikit-learn, the Python package, are fantastic. If you want to try things out, try Kaggle. It's a machine learning competition board. So, get all your friends to do it too and then beat them and laugh. You can do Azure Notebooks examples. There's a thing called TensorFlow Playground for visualizing out deep learning networks. And you can also attempt your own project. That's really the best way to learn. So again, thank you so much. I'm sorry I went a little bit over time, but I really enjoyed this.